Introduction. Motion is common to everything in the universe. We walk, run, and ride a bicycle. We see leaves falling from trees and water flowing down a dam. Automobiles and planes carry people from one place to the other. The earth rotates once every 24 hours and revolves around the sun once a year. The sun itself is in motion in the Milky Way, which is again moving within its local group of galaxies. Objectives. At the end of this lesson, you'll be able to understand mechanics and its classification, distinguish between statics and kinematics, distinguish between rest and motion, understand relative motion, understand types of motion, define point mass object and frame of reference, differentiate between path length and displacement, difference between speed and velocity. Mechanics and its classification. All living things move by themselves without any external help. Animals move from one place to another, or they move their body parts, are all motion. The branch of physics which deals with the study of motion of material objects is called mechanics. Mechanics is broadly classified as 1. Statics, 2. Kinematics. Statics and kinematics. Statics. The branch of mechanics which deals with the study of objects at rest is called statics. It is the study of motion of objects under the effect of forces in equilibrium. Time factor plays an important role. Kinematics. The branch of mechanics which deals with the study of motion of objects and the factors which causes motion. The force is the cause of motion. Time factor plays an important role. Rest and motion. Rest. An object is said to be at rest if it does not change its position with time and with respect to its surroundings. When the book lies on the table or a person sitting in a chair shows rest. Motion. An object is said to be in motion if it changes its position with time with respect to its surroundings. A bird flying in air, a ship sailing on water are examples for a body in motion. Rest and motion are relative. A person sitting in a moving train is at rest with respect to his fellow passengers, but is in motion with respect to the objects outside the train. This is the situation when object in one situation can be rest, but in another situation the same object is in motion. Hence, rest and motion are relative to each other. Example. A person sitting in his house is at rest, but with respect to Earth, it is in motion with respect to other planets. Types of motion. Motion is of three types. 1. Rectilinear motion. When body is moving along a straight line is called rectilinear motion. 2. Circular motion. When body is moving on a circle, it is called circular motion. 3. Oscillatory motion. The to and fro motion repeatedly about a fixed point in definite time interval of time is called oscillatory motion. Point mass object. Object is a point mass object if during motion in a given time it covers distances much greater than its size. Example, the revolution of Earth around the Sun, the diameter of Earth being very small as compared to the length of the orbit around the Sun, the Earth can be regarded as the point object. Frame of reference. The system of coordinates axes, three straight lines inclined to each other at right angle, attached to an observer origin with respect to which the observer can describe position, displacement, velocity, acceleration, etc. of a moving object. It consists of three coordinates x, y, and z with origin O at the starting point of the particle. Motion in 1, 2, and 3 dimensions. One-dimensional motion. The motion only in one out of three coordinates specify the position of the object changing with respect to time. Example, car traveling in a straight line. Two-dimensional motion. The motion of an object in 2 out of 3 coordinate specifying the position of object change with respect to time. Example, a billiard ball moving over a billiard table. Three-dimensional motion. The motion of the object, when all the 3 coordinates are specified, the position of the object change with respect to time. Example, a kite flying on a windy day. Difference between path length and displacement. Path length. The total path length is the actual distance travelled by the object in a given time during motion. It cannot be zero. It is a scalar quantity. Displacement. The shortest distance between the two positions of the object in a particular direction during that time is called displacement. It can be zero. It is a vector quantity. Speed of an object is defined as the ratio of the total path length covered and the time taken by the object. Therefore, speed is equal to path length upon time interval. It is scalar quantity. SI unit is ms raised to the power minus 1. Dimensional formula m raised to the power 0, L raised to the power 1, T raised to the power minus. Uniform speed and variable speed. Uniform speed. when the object covers equal distance in equal intervals of time is called uniform speed. Variable speed. When object covers equal distances in unequal intervals of time or unequal distances in equal intervals of time, it is called variable speed. Average speed and instantaneous speed. Average speed. The ratio of total distance travelled by the object to the time taken. Therefore, average speed is equal to total path length upon total time interval. Instantaneous speed. The speed of an object at a given instant of time is called instantaneous speed. Velocity and its types. Velocity. Velocity is defined as the ratio of displacement to the time interval taken by the object. Therefore, velocity is equal to displacement upon time interval. It is a vector quantity. SI unit is m upon s. Dimensional formula is equal to m raised to the power 0, L raised to the power 1, T raised to the power minus 1. Uniform velocity. When object covers equal distance in equal interval of time is called uniform velocity. Non-uniform velocity. When object covers equal distance in unequal interval of time or vice versa, it is called non-uniform velocity. Graphical representation of motion. Distance-time graph. The distance-time graph gives us the speed. The slope of a distance-time graph gives speed. If the distance-time graph is a straight line, the speed is uniform. If the distance-time graph is a curved line, the speed is non-uniform. Did you know? Motion in the universe is described through two sets of apparently contradictory laws of mechanics. Motions of all large-scale and familiar objects in the universe, such as projectiles, planets, cells, and humans, are described by classical mechanics. The motion of very small atomic and subatomic-sized objects is described by Summary. Let us summarize what we have learned. Change of position is called motion. Motion in terms of distance is called speed, and in terms of displacement is called velocity. Motion can be uniform or non-uniform depending upon velocity, which may be constant or changing respectively. The rate of change of distance or displacement gives us speed or velocity respectively.